Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the aldol condensation reaction, and as we know that aldol condensation reaction it involving as a Carbanion, because we are talking about the reaction involving Carbanion, and that aldol condensation reaction it is belonging to as a nucleophilic addition reaction. And first simple aldol condensation reaction we have seen last lecture. Now let us see some of the application of that aldol condensation, or sometime predict the product. How do you predict its product? Because you know that the mechanism of that aldol condensation reaction, and now you are able to predict the product. Now tell me whether you are able to draw the product CH3, C double bond O, then CH3, 2 moles of this, and that will be treated with the dilute sodium hydroxide NaOH. What will be the product A? And in the second case you are treating with just heat it, what you are going to get, that is the product number B. Now tell me, because we are just we have seen whether you are understood these aldol condensation reaction, simple aldol condensation reaction. I am just checking whether you understood it or not. Let us see here 2 moles of that acetone. As we know that acetone fulfilling all the requirement of aldol condensation reaction. That aldol condensation reaction occur or take place when there is a carbonyl compound, maybe as aldehyde or the ketone, but that compound must have a alpha hydrogen atom in presence of the dilute NaHO, sodium dilute alkali, and there is a condensation takes place between as a 2 molecule, and resulting compound formed is a beta hydroxy aldehyde or ketone, or which is simply referred as a aldol. That is a common name, and we are getting that type of the product. And these, as we know that aldol are a very unstable compound. Just heat it at 100 degrees centigrade, there is a elimination of the water molecule takes place, and resulting compound is formed as a very stable, and that compound is referred as alpha beta unsaturated aldehyde or the ketone, and or we can call the common name of this compound is a chalcone. And therefore now how do you predict that product? Now look at here, this carbonyl compound, this is a carbonyl compound, there are adjacent carbon atom, this is also as alpha hydrogen atom. So there are 6 alpha hydrogen atoms are there. So if you remember the first reaction, its mechanism, and then you can able to predict the product. If you don't know the mechanism, you cannot write the product perfectly. So for predicting the product, you must know the mechanism behind it, and then because I am knowing the mechanism, and that's why I can predict the product very easily. Let's see over here. Suppose as this one CH3, then here I am writing suppose as OH, then CH3, then CH2, C double bond O, and the CH3. That is the A product I am getting over here, and this is known as a aldol, right? Aldol, or I can call it as a beta hydro, alpha and beta. Look at here, what you have to remember over here. Look at in the starting compound how many total carbon atoms are present. Look at 1, 2, 3. There are 3 carbon atom, 1 molecule, and 3 carbon atom of another molecule. Total are 6. Now count here. Is there a 6 carbon atom here? Yes. 1, 2, 3, 4, 5, and 6. And that's it. They condense together, and resulting compound is aldol. And when heated it, so what is going to get? The alpha have 1 hydrogen from here and OH from here. You are going to get CH3 over here. Then this CH3. Now the double bond here, and CH. C double bond O, and the CH3. This is the alpha beta unsaturated compound, and therefore this is the B product. Understood this one? And these are the application of that simple aldol condensation reaction. Suppose another one. Now let us, this is a second example. Now let me tell you let me consider here one more example over here. Let us see 2 moles of pH C double bond O CH3. What I have taken over here is a acetophenone. Name of this compound is acetophenone. 2 moles of acetophenone undergoes the condensation reaction, aldol condensation reaction in presence of the dilute sodium hydroxide. Resulting compound form is the aldol. Here again is the same reagent I am considering over here, dilute sodium hydroxide, NaOH, A product, and now just heat it, you are going to get as a B product, right? This triangle is nothing but as a symbol of heating, and after heating we are getting as a B product over here. This is the acetophenone, as we know that common name of this compound is acetophenone. And now here this is the common name of this compound is acetone, right? This is a acetone common name, and acetone gives the A product like this, and this is a B product. Here just remember, is there a first find out, first identify, first recognize, is there a alpha hydrogen atom present? Yes, there is a alpha hydrogen. Here this is a carbonyl group, this is alpha hydrogen atom present in the carbonyl, adjacent to the carbonyl carbon is known as alpha carbon, and whatever hydrogen present on it, whatever hydrogen atom carry that carbon atom are termed as a alpha hydrogen atom, and therefore this type of the molecule undergoes easily or the readily aldol condensation, simple aldol condensation I am talking about, and the resulting compound is formed over there. Let me write here how you will get here pH, then OH over here, then CH3 I am writing as it is, then CH2, C double bond O, and the pH. Right, this is because I am knowing the mechanism, you also knowing the mechanism. In a previous lecture we have seen detail the mechanism of this, and that's why I am also and you are also able to predict the product. A product is a very perfect one. This is alpha, this is beta, is known as a beta hydroxyketone. Beta hydroxyketone, this one ketone, or we can simply say that it is a aldol, right? So this is a aldol over here. Now what would be the B product? Just look at here, there are 2 hydrogen, one of them you remove from here and OH from here. What you are going to get? You are going to get over here, this is a pH, then C, the methyl group as it is over there, and then now there is a double bond here CH, and then C double bond O pH, and this is a alpha beta unsaturated compound, alpha beta unsaturated compound, or it is known as a chalcone. This is alpha beta unsaturated, alpha beta unsaturated ketone, or which is known as a chalcone. Remember, chalcone is a very stable compound formed over there, and that's why it is a aldol, simple aldol condensation reaction. These are the some of the additional example I have taken over here, so that you can understood the simple aldol reaction very perfectly or cleanly. Now let us move on to the next point. What we are going to discuss is the cross aldol condensation reaction. Next reaction would be the crossed aldol condensation reaction. Second one is a crossed aldol condensation reaction. Now is a crossed aldol condensation reaction. Cross aldol condensation reaction, right? Cross aldol condensation reaction we are talking about over here. And what do you mean by the cross? In a botany you might be seeing hybrid, cross. So that type of the things are there. In a simple aldol condensation reaction require the two molecule of same way, they may be as a aldehyde the ketone, but same molecule, they undergoes the aldol condensation reaction, and that type of the reaction is called as a simple aldol condensation reaction. Two molecules get condensed together, there will be a formation of the carbon-carbon new bond, because that is the this reaction involving as a carbanion, and therefore condensate, there is a formation of the new carbon-carbon bond, and that's why the aldol condensation reaction is synthetically very, very important. Just by cross aldol condensation reaction, in a cross aldol condensation reaction, here the criteria is remains as the same, but some of the other additional new point you have to remember. Crossed means what? Two different molecule, maybe aldehyde or the ketone, two aldehyde may condense, but that should be as a different one. And if you take here the two example of this, then this cross aldol condensation reaction is giving us a lot of side products are there, self condensation reaction as well as crossed condensation reaction. Suppose, let me tell you with that example. Suppose we have a starting compound is this one, CH3 C double bond O. One I am taking as a one is acetaldehyde, right? Another molecule I am taking over here is acetone, CH3 C double bond O and CH3. Right, and this CH3 I am treating this compound, and this is called as a cross aldol condensation reaction. First one I am treating this with first one, what we can call it as a first one is a dilute dilute sodium hydroxide, NaOH, dilute sodium hydroxide, and further just by heating as a heating. So I am directly one step I am skipping over there, so that you can understood over there. Two different molecule, because that is a cross means one is aldehyde, one is a ketone, two different molecule. Or you may take as a you may take here CH3, CH2, C double bond O and H like this. Still there is a cross, because this is a acetaldehyde, this is a propanaldehyde. But different molecule, two different molecules are there, and therefore the reaction takes place between them, and the criteria remains same. There must be as a alpha hydrogen atom, and then dilute alkali is used and condensed together to form as a new carbon-carbon bonds over there. And now but the synthetically this cross aldol condensation reaction, if you use such type of the reaction, you are getting as a mixture of, here you are going to get as a four type of the product, four products are there, and if number of products are four, there is a lot of difficulty for separation. You have to use as a different technique for separation, and therefore to isolate, to obtain the pure product is a very difficult in such a case, and therefore synthetically I will explain that one later on. They are synthetically, which one is a cross aldol condensation also as a very useful, when there is a that I will explain after some time. Now let us look how we are getting as a four different product over there. Two are the self aldol condensation reaction, and two are crossed aldol condensation reaction. Let us see over there. Two are self aldol condensation reaction like this. Here we are going to get, suppose as a CH3, then CH double bond CH, then C what we can call it as a C double bond OH, one of the molecule we are going to get over here. Another maybe as this one CH3, then here CH3 double bond, I am writing here CH, C double bond O, CH3 over there. So these are called as a self condensation reaction, self aldol condensation reaction. Self aldol condensation reaction means what? these two molecule of acetaldehyde resulting this compound first, and two acetone molecule they undergoes as a self aldol condensation reaction. We are getting resulting compound is the second one, right? Now this one is a first one, this one is a second, we can call it. And now now the third one, which one? Let us see over here. Third one will be like this. Here CH3, then CH3 double bond, then CH, C double bond OH, and the fourth one may be as this one. Let us see here, CH3 CH double bond CH, then C double bond O, and the CH3. These are the different compound, and these two third and fourth is called as crossed aldol condensation. Crossed aldol condensation. Cross aldol condensation. So there are four product we are getting, means mixture of product. There is a lot of problem for separating such type of the molecules are there, and therefore that cross aldol condensation reaction has some limitations are there. Look at here, four different products. Are these four are a different product or not? Yes. Look at this one is a totally different, but alpha beta unsaturated moiety remains as the same, and other thing are different only as a substituents are different over there. And this chalcone alpha beta unsaturated compound, they are remains throughout in this. And look at when these two molecules, this already we know that when these two molecule means carbanion form on this acetaldehyde, and the that carbanion or that enolate ion reacting with the another molecule of acetaldehyde, that resulting we have seen this in the simple aldol condensation reaction, that is the crotonaldehyde or the chalco. And now when this acetone react, carbanion is formed on acetone, again that carbanion is going to attack on the another molecule of acetone, the resulting product will be obtained as a this one. Look at here, total number of 6 carbon atom, 1 2 3 4 5 and 6. In this case, two molecules of 4 are there, 1 2 3 and 4. Look at here. Now when this and this, when the carbanion form on it and it is going to attack on this, then and then you are going to get as a this acetaldehyde group is there. And now when the carbanion is formed first in the first step on the acetone, and that is going to attack on this, and then at that moment you are going to get as a this type of the product. This product and this product, they are the different one, but the number of carbon they are condensed together, number of carbon atom in the product observed are the same. Look at here, 1 2 3 4 5. Here also 1 2 3 4 and 5. 5 carbon atom means 2 from the acetaldehyde and 3 from acetone. Total becomes as a 5, and therefore that type of the condensation is called as a cross aldol condensation reaction. And now let us look at the how we are getting as a when we are going to learn as a mechanism. The mechanism of these two we already seen. Now third and fourth, let me write that third one over here, CH3, then one CH3 over there, double bond CH, now is a C double bond OH. This is the third one, and the fourth one I am writing piece here, CH3, then CH double bond CH, then C double bond O CH3, right? And now I am cleaning the board over here so that we can write the mechanism here more clearly, so that you can understood how we are getting as a product number third one. Now let us begin, because first and second we have seen that is a self, now is a cross. What is going to happen here in this particular case, CH2, I am writing one of the hydrogen atom over here for the suitability point of view, and that OH minus will abstract this proton and form the carbanion over there, and you are going to get CH2, then C double bond OH, that carbanion form over there. This species is known as a Carbanion. This is a step number first we are talking about, and now this Carbanion further undergoes into the delocalization, and we are going to get over here CH2 double bond CO minus and the H over here, right? There are the two different ways to draw the delocalized structure. That is the meaning of double-headed arrow. That is a resonating structure, the two different ways to represent the same molecule, right? So these two different ways we are writing. This is a Carbanion and this species is known as a enolate, right? And now another molecule. This is a one of the acetaldehyde molecule. In the second step, what we are going to use here, acetone. For the sake of convenience, we are writing C double bond O and CS3 over here, so that we can see the mechanism clearly over here. Then CH2 double bond CO minus and the H, because we are trying to derive that product, and that's why we are taking over here that negative charge forming as a double bond with that oxygen, and this double bond is going to attack on this carbonyl carbon, and negative charge develop on that oxygen atom. You are going to get here CH3, then CO minus, methyl group 1 over here, then CH2, then C double bond O, and that hydrogen atom as it. That is the epoxide type of the compound. And now in the third step, what is going to happen in the third step? That is a protonation step, because this mechanism involves 4 steps. Now here CH3, then CH3 over here, O minus, then CH2, C double bond O, H. I am writing this molecule as it is, whatever over here, and now here is a hydrolysis H. I am writing here H, that is positive charge over there, that is a protonation. This negative charge is going to pick up the proton from here, neutralizing that positive charge, and the resulting compound obtained will be CH, then here CH3, here is a OH, now here is a CH2, then C double bond O and H over here, right? And this is known as a beta hydroxy aldehyde, or we can call it as a what we can call it as a, that one we will be the aldol, right? Aldol is a very unstable compound, and therefore CH3, then OH from here, CH3. Now I am writing this CH2 in this way or in this fashion. One hydrogen I am specifically showing like this, C double bond OH. What I write this compound as it is over here, just here is a triangle indicate as a heating symbol. Now one hydrogen from here, H from here, forming as a double bond, and there is a elimination of the water molecule H2, and you are going to get as a alpha beta unsaturated compound, which is this one, CH3, then here CH3, CH3, and now double bond CH, then C double bond O and H. If you compare these two, compound number 3 and 4, if you observe carefully, what do you see? They are the identical, means we have derived this that is called as a cross aldol condensation reaction. Now let us see another one more example over here. So how do you get that fourth one? Let's begin with this fourth one, this one, CH3, CH double bond, CH3. Now what you are going to do, you think you over here, now take the acetone atom here, CH2, H I am taking as acetone as a starting compound, and then C double bond O and CH3. I am now going to form the which one, carbanion on the acetone here, abstracting that proton and form as a carbanion over there. Here you are going to get CH2 minus charge, then C double bond O, CH3. Look at over here, this is a carbanion, right? Carbanion, and further delocalization takes place. this negative charge forming as a double bond over there, and negative charge develop on that oxygen atom. You are going to get CH2 double bond, CO minus, and then CH3, right? And this passage is known as a enolate. The passage, you remember the negative charge adjacent to the carbon-carbon double bond. This is a step number first. Now let us look at the step number second. In the step number second, let us see here the acetaldehyde molecule, and we can write the acetaldehyde molecule in this way so that we can represent, we can show the mechanism very clearly. CH2 double bond, CO minus over here, CH3. Now what is going to happen? This negative charge forming as a double bond with that oxygen, this double bond attacking on a carbonyl carbon, and negative charge now developing on that oxygen atom, and you are going to get here. Observe this mechanism carefully, because as we know that organic chemistry is a very volatile, and now this hydrogen atom I am writing here, and now there is a new carbon-carbon bond is formed over there, and now here C double bond O, and this methyl group as it is. That is a alkoxide type of the, and now in the third step is called as a protonation. What is going to happen here? CH3, CH, and that O minus I am writing as it is, then CH2, C double bond O, CH3. Here the protonation is, or that hydrolysis is carried out positive charge. This is called as a protonation step. In this process, this negative charge is going to attack or abstract the proton from this protonated hydroxyl ion, and we are going to get over here CH3, then CH I am writing over there, OH over here, then this CH2, and then C double bond O, and the CH3. Look at this one. Again alpha and beta position, there is a hydroxy group, and therefore it is known as aldol. Now I am writing this molecule as it is in the step number 4, which is called as a heating process or loss of water molecule over here. CH3, only one change I am making over here. I am writing this CH2, one H along with that hydrogen, and one hydrogen I am specifically shown like this, so that you can understood how the water molecule get eliminated. From alpha position there is a hydrogen atom, and from beta position is a hydroxyl groups are removed, means just by heating removal of water molecule H2O, and you are going to obtain, or you are going to get CH3, then CH double bond, then CH, C double bond O, and the CH3, right? And now this way you can show as a mechanism. And now look at, observe these two molecule carefully. What do you see over here? This molecule and this molecule, one and the same molecule, and therefore in this way, remember, if you know the mechanism perfectly, then you can predict the product very easily. And now this is a lot of the four product we are getting means mixture of the product, and if the mixture of the products are there, there is a very difficulty to separate these products from each other. So how do you separate these? There are the different technique for the separation, but to avoid such a type of the separation method, to isolate that compound, for that purpose what the aldol done, he carry out the reaction, he specifically chosen the starting compound in a such a way that only one of the aldehyde or the ketone must have a alpha hydrogen atom, and another carbonyl compound do not have a alpha hydrogen atom, then and then they obtain as a single and only pure product. So that is the main objective, what we can call it as a significant of this reaction, to get the product in a higher percentage, higher yielding of the product. So that's the utility of as far as organic synthetic chemistry is concerned, and therefore let us see for synthetic application of the aldol condensation reaction. Cross aldol condensation reaction is a very high yielding product is obtained. How that getting? He selected one of the compound. For example, the reaction is carried out between CH3, C double bond OH, and another molecule maybe as a this one acetaldehyde, right? This one. First, both are the aldehyde, but is there aldol condensation reaction possible, or is this reaction undergoes aldol condensation reaction? Yes, because here there are carbonyl compound, no doubt, and one of them has a alpha hydrogen atom. The criteria required for the cross aldol condensation reaction, there must be one of the aldehyde or the ketone must have a alpha hydrogen atom, and then another molecule should not have alpha hydrogen atom. Then and then aldol condensation reaction takes place with higher yielding product is getting is a more than 90%, and therefore this is a synthetically synthetic point of view is a very important aldol condensation reaction, and therefore now just it is hitting with dilute NaOH, sodium hydroxide. Second one will be just as a heating. What you are going to get? The product here you are going to get only and one product, no separation required, and that is the main objective aim of this aldol condensation reaction. And here you are going to get the product CH2 double bond, then CH, C double bond O is this type of the crotonal what is that? I think this alpha beta unsaturated compound, alpha beta unsaturated, only one product we are getting, that is alpha beta unsaturated compound over here. That is a crotonaldehyde, I think, not crot. Previous one we have seen crotonaldehyde. This is a common name of this chalcone or alpha beta, just now you remember, and tomorrow I will tell you the correct name of that compound. Right now I am not knowing the name of that specific of this compound. Just remember it is alpha beta unsaturated compound, no doubt about it, but here it is called as a chalcone, common name is there. So how we are getting as this one? Now let us look at as a mechanism once again over here. Now because carbanion we can form only on one molecule, because this molecule has a alpha hydrogen atom. This molecule there is no alpha hydrogen atom, and therefore you cannot form as a carbanion over there. And therefore now let us see here in the first step CH2, here H, then C double bond OH. Now OH minus can abstract the proton from here and form as a carbanion. CH2 minus charge, then C double bond OH. Now delocalization takes place, is forming as a double bond over there, negative charge over there, then CH2 double bond CO minus and hydrogen atom over there. This species is known as a enolate, right? This species is known as a enolate. Now this is a step number first. Now look at the step number second. In the step number second we can write this formaldehyde. This is acetaldehyde, right? Acetaldehyde, and this is known as a formaldehyde. Formaldehyde. This is the common name of this compound. The IUPAC name of this compound is ethanol. This one is a methanol. Remember. And now here this formaldehyde I am writing like this, and plus this enolate species. CH2 double bond CO minus and this hydrogen. Now what is going to happen? This negative forming as a double bond over there, and this double bond attacking on that carbonyl group, and we are going to get here is a product HCO minus hydrogen atom over here, then CH2, then C double bond OH. This type of the product we are, this is a what we can call it now is a protonation can be carried out over here H, then CO minus hydrogen atom over there, CH2 C double bond OH, and now what I am going to take as here HOH, hydrogen atom positive charge over there, protonation this way, and you are going to get H, then OH, this H here, and then CH2 C double bond OH. Now look at this alpha and beta position hydroxy group is there, and therefore it is known as a aldol or the beta hydroxy aldehyde. And in the fourth step, what is going to happen? Write down this molecule as it is over here, H, then OH, H I am writing over there. For sake of mechanism point of view, I am writing hydrogen atom over here, C double bond OH, just heat it, minus water molecule get eliminated, 1H from here and OH from here, and we are going to get the product, this one CH2 double bond CH, C double bond O and H. This is alpha beta unsaturated compound. This is the mechanism. If you know the mechanism, you can predict the product very easily by knowing the mechanism. Now I am going to give some more examples so that you can, now you know the mechanism very well. I think now you just predict the product over here, and synthetically it is a very important step as far as the organic chemist point of view is concerned, because there is a formation of the alpha. Now let us see here I am taking one of the example over here is this one CH3, then C double bond OH acetaldehyde, that will be treated with benzaldehyde C double bond OH, as we know that. Then predict the product A, and then further treated with heat, here dilute NaOH, and here will be the B. Another, what type of the product you are going to get? Here you are going to get aldol, here you are going to be. Only one products are possible, because only acetaldehyde has alpha hydrogen atom, benzaldehyde do not have a alpha hydrogen, therefore the product you are going to get in this case will be this one pH, then CH-OH, then CH2 C double bond OH, because we are knowing the mechanism, and that's why we are predicting the as a product very perfectly. And B product, just heating it, we are going to get here pH, CH double bond CH C double bond OH, that is alpha beta unsaturated aldehyde, that is a cinnamaldehyde we are going to get over here. Suppose you have this one, suppose pH C double bond OH, I am writing just CH3 C double bond O and the CH3, what will be the A product, and after heating what will be the B product. Here dilute sodium hydroxide I am giving over here, and now heating. Can you able to predict the product? Yes, because now you are knowing the mechanism. Once you know the mechanism, you can predict the millions of the product, because once you know the mechanism. Now look at here, only just I am writing this acetaldehyde over here, this, but that beta, that acetophenone has a alpha hydrogen atom, and therefore this compound undergoes as a what we can call it as, it undergoes as a aldol condensation reaction, and A product here you are going to get pH, then what here CH-OH, and then CH2 C double bond O, here is a CS. Instead of that, what we can call it as a H, I am taking as a methyl group over there, and just heat it. What you are going to get pH, then CH double bond CH, then C double bond O, and the CH3. That will be the B product over here. So suppose I am taking over here, let me here, suppose you have this one is a benzaldehyde, another one is maybe as this one pH C double bond O pH, and first one dilute NaOH, second one would be, what is that, just heating. Is there reaction takes place? No, there will be no reaction, because in this case no aldol condensation reaction. Sorry, here is a C double bond OH, benzaldehyde, there is no alpha hydrogen, no alpha hydrogen atom, here also has a no alpha hydrogen atom, therefore no reaction, remember. So this type of the benzophenone and benzaldehyde do not undergo the aldol condensation. Some other reaction may occur, but aldol condensation reaction is not possible in this case. I think with this we have seen enough example of that remaining reaction like as a cross aldol condensation reaction. We have seen how it is synthetically useful, that is also we have learned, and tomorrow we are going to see the intramolecular aldol condensation reaction, or it is known as a Dickmann cyclization reaction. Why it is called as a Dickmann cyclization, that also the reason behind it, that we will see tomorrow. Let us stop today here. Have a nice day. Thank you.